Okay, let's get it started. Can you see my screen? Just give me the thumbs up if you can see it. Can you see my screen, beautiful people? Yes, okay. And can you hear me also? Good. So we are all set here. Let's begin today's lesson. Today we'll be working on, still working on function, but here we are looking at a new concept on function, okay? So we are pretty much heading towards the operation of function. And the first thing that we are going to do, and we are going to work today, is the inverse functions. Okay, we are looking at a concept of inverse function. Let's find out what are inverse function, how we can do the math to find the inverse function, how we can create the graph, and so on. First, we'll look at the definition of inverse function. And whenever we are looking for inverse function, we can find the inverse function of one-to-one function only. We cannot find the inverse function of every function. Your function must be one-to-one function, then only we can find the inverse function. So what I mean by that, if you look at this mapping diagram here, you can see that from the first set, you can call from set A to set B, there is a function f. Okay, from set A to set B here, there is a function f. And if you look at this function carefully, you can see that this first element, A1, is mapped with only one element, B1. A2 is mapped with only one, B2. A3 mapped with only one, B3. And A4 is mapped with only one, B4. If one element of domain is mapped with only one element of the range, then we say that this function is one-to-one. One element mapped with one, okay? For one input, there is one output. Or you can say for one output, there is only one input. So if you have a function like that, that's called one-to-one function. That is when we have the mapping diagram. But if we have the graph, in order to check whether it is one-to-one function or not, what we normally do is we draw the horizontal line, not the vertical line. We draw the horizontal line. For example, in the second graph, we have the graph of the function. In the second picture, we have the graph of the function. We draw the horizontal line, not the vertical line, okay? If the horizontal line crosses the graph at only one point, here you can see the horizontal line crosses the graph at only one point. If the horizontal line crosses the graph at only one point, then this is one-to-one function. Okay, this is one-to-one function. Similarly, this one, the first diagram where we see one element mapped with only one element, that's also one-to-one function. So if the function is one-to-one function, then what we can do is we can find the inverse of the function. So here in the first diagram, from set A to set B, we have the function f. Now we can define another function from set B to set A in the opposite direction, from B to A. You can also define a function from set B to set A, and we call that function inverse function. And we write it like this. We write f with -1 on the top like this. Okay, this is not f raised to -1, but this is the symbol for the inverse function. Okay, this is the symbol for the inverse function. Remember, in regular arithmetic, what we know is if we have the numbers like, say, for example, 2 to the -1, 2 to the -1 is equal to 1 over 2. That is the meaning in case of numbers, right? 2 to the -1 is equal to 1 over 2. Or maybe we can say a to the -1. If a is some real number, then a to the -1 is equal to 1 over a. These are true for real numbers, okay? If we have a negative exponent, that is the reciprocal, and that is true in case of real numbers. But very important for you to note here, if we are talking about f inverse, there is also a little -1 there. But remember, this is not the reciprocal. F with the -1 and then x, this is the inverse function. This is not equal to 1 over f of x. They are different. They are not the same thing. Okay, they are two different things. So that is the key over here. In order to find the inverse of a function, your function must be one-to-one. When I say one-to-one, if you look at the mapping diagram, you'll see that from the input set and to the output set, there will be one-to-one mapping. If you have a function like that, that's one-to-one function. Or if the graph of the function is given, you can always draw the horizontal line. And if that horizontal line crosses the function at only one point, then that is the one-to-one function. And this line that we are drawing here to test the function, this test is called the horizontal line test. This is the horizontal line test. We use the horizontal line test to determine whether the graph of the function is one-to-one function or not. If the horizontal line crosses the graph at only one point, then that is one-to-one function. Otherwise, it is not the one-to-one function. So once we have this basic concept, we are going to look at two important properties of the inverse function, which we'll be using today. Before we move on to that, I want you to copy everything from this slide. Okay. So for that, I'm going to give you about a minute or so here. And also, if you have question, you can send me the questions through chat, or you can unmute yourself and ask question. Are we done copying it, Diksha? Done. Okay, let me check with you one more here. Pooja, are we done copying it? Pooja, are we done copying it? Yes, no? Okay, you send me a message. Yes, okay. So look like we are ready. So let's move on to a next slide and look at the properties, important properties of inverse function that we'll be using today. So here we have two important properties of inverse function, and these are used when we do the actual math later on involving inverse function. The first one is the graph of the function f and its inverse, denoted by f inverse, are reflection of each other about the line y equal to x. So look, if you look at this first graph here, here we have the graph of the function f of x. Okay, here in blue, we have the graph of the function f of x. And here we have the graph of f inverse x, which is in green. Okay, the graph in blue and graph in green are inverse of each other. And you can see that these are reflection about this line here, the dotted line, y equal to x. And how do we know that these are reflection about that line? You can just look at the points on the graph. For example, if you look at this point here, look where I'm pointing. The coordinate of that point, okay, where I am pointing. Sagar, what is this point? Please unmute yourself. Sagar, unmute yourself. Tell me, what is this point? Sagar, please unmute yourself. What is this point?
When we have your cursor?
Yeah, where I'm pointing?
1, 0.
1, 0. Very good. That point is 1, 0. Now see, we are reflecting. Don't mute yourself, Sagar. I'll ask you second question. As we are talking about reflection about the line y equal to x, whenever we reflect about the line y equal to x, the x and y coordinate will switch. Okay, x and y coordinate will switch. So here on this blue function, the point on the graph over here is 1, 0. Now, Sagar, look where I am pointing. Okay, look where I am pointing. Let me also put a dot there. What is the coordinate of that point now?
0, 1.
0, 1. Very good. Thank you so much, Sagar. 0, 1. So you can see that the point on the original function is 1, 0. When you go here, it is 0, 1. You can see that the point are switched. Okay, x and y coordinate are switched. This is because the graph of the function and its inverse are reflection about the line y equal to x. We can also check one more point. Let's see this point here on the graph of this function y equal to f of x. This time, let me ask Prakriti to read this point. Unmute yourself, Prakriti, and tell me what is this point. Prakriti, please unmute yourself.
4 and 2.
That is 4, 2. Very good. 4, 2. Now, if you look at the reflection, Prakriti, reflection of this point is over here where I am pointing, right? That is the reflection of this point about the line here where I'm pointing. What is that point now?
2, 4.
2, 4. Very good. That's 2, 4. Thank you, Prakriti. So you can see that very clearly. You can see that the graph of the function, like the one here shown in blue, and its inverse shown in green, they are the reflection about the line y equal to x. Whenever we reflect a point about the line x, y equal to x, see, let me write here. If you have a point x, a, comma, b, if we have a point a, comma, b, and we reflect about the line y equal to x, the image will be b, comma, a. Okay, the image will be b, comma, a. And that is seen here very clearly. As Sagar reads the first one, 1, 0 becomes 0, 1. And similarly, this point as read by Prakriti, you can see 4, 2 becomes 2, 4, right? So the x and y coordinate will flip. In other words, the graph of the function and its inverse are reflection of each other about the line y equal to x. And this concept is very important because you can see if a function is given to you, okay, if the function is given to you and you want to find the inverse of the function, then y becomes x and x becomes y. So technically what you can do is you can change x and y to get the inverse function. Okay, that is one important thing. Second thing, if you look at this mapping diagram here in the second picture, this is just like the mapping diagram that we have seen here in the first slide. So here we have a function from, let's say, from set A to set B. Okay, from set A to set B, there is a function fx. Okay, f of x. Say, for example, this is one-to-one function. That means if this is one-to-one function, we can define the inverse function from set B to set A. As you can see here, from set B to set A, there is an inverse function. So the first function f is going from A to B. That means the domain of function f is this first set. And range of the set will be, or range of the function will be set B. Okay, for the function. But for the inverse, as it is going in opposite direction, the second set will be the domain of the function inverse. And then the first set will be the range of the inverse function. So that means the output of function f, when I say output of function f, if this is the function f, the output is this set b. Okay. Output of the function f are the input of the inverse, because the inverse defines from b to a. Okay. And meaning of that is the range of function f is the domain of the inverse and vice versa. That means for the function f and its inverse, the domain and range are interchangeable. Domain of f is the range of f inverse. You can clearly see in the diagram. See, domain of f is the range of f inverse, but the range of f is the domain of f inverse. That's why the domain and range of function and its inverse are interchangeable. Okay, that is very important concept that you should know. So these are the two very important properties of inverse function that we'll be using today. Okay, so finish up your writing. In the meantime, as you're writing, if you have any question, you can ask me, you can unmute yourself and ask, or you can send your question through chat. Look like there is no question. Let's check whether you are done copying it or not. Karina, are we done copying this?
Yes.
Yes. Okay. Okay. So let me give you one important thing here besides these 2 points. If you try to find the composition of the function and the inverse, we know how to find the composition. So if we want to find the composition FO, F inverse X, that is the composition. Okay. If you want to find the composition of function and the inverse, you can do FO, F inverse X, or F inverse O, F of X. Either way, these two values will be equal. If these two functions, F and F inverse, are inverse of each other, then the composition of function and the inverse are equal, and your result is always equal to X. That is, whatever is the input, you'll get the same output. Meaning of that is the composition of function and its inverse is an identity function. So you can also add this as a third property if you want. The composition of function and its inverse is an identity function. Meaning of that is whatever is the input, you'll get the same output. So F O F inverse X and F inverse O F of X are equal, and it is always equal to X. So we use this to check whether the given functions are inverse of each other or not. You cannot just check one composition, but you have to check both compositions, and it should be equal to X. Okay. Now let's see how we can use this third property. Let's begin with that. Here is a question. You can see example. Are the functions f of x equal to 1 over x plus 2 and g of x equal to 1 over x minus 2 inverses of each other? We have to test this one. First, copy the question, and we are going to talk about it. Okay, let's talk about it now. See, two functions are given, and we have to check whether these two functions are inverse of each other or not. Meaning of that is, if you try to find the inverse of f of x, you should get g of x. And if you want to find the inverse of g of x, you should get f of x. But we are not actually finding the inverse. We are not asked to find the inverse. We are asked to check whether these are inverse or not. So what we do is we take the composition. We find FOG of x and GOF of x. If we get x as the answer in both cases, then we say that they are inverse of each other. Otherwise, they are not the inverses. Okay, so let's check it. So first thing that we need to do here is we have to find the composition FOG of x. We have to find the composition FOG of x. So FOG of x, meaning of that is inside the function f, you have to plug in function g of x, right? Inside the function f, you have g of x. Or we can also write like this. This is equal to f of, we write the value of g of x now. G of x is 1 over x minus 2, 1 over x minus 2. Okay, it becomes f of 1 over x minus 2. Now, see, we are evaluating this function at 1 over x minus 2. If we are evaluating f of x, it will be 1 over x plus 2. If we want to find f of 7, say, for example, it will be 1 over 7 plus 2. In place of this x, we write that value. So in place of this x here, where I'm pointing, over there, we write 1 over x minus 2. Okay, so it will be 1 over, in place of x, we have to write this value, which is 1 over x minus 2. Then we have a plus 2, as you can see there, right? Then, okay, somehow, I hope you can see it now. So see, what I've done is in place of x, I wrote 1 over x minus 2, and this plus 2 as it is. Okay, now you can see there is a negative 2 and positive 2 in the denominator, and you can cancel them. Okay, you can cancel those two. So it becomes, let me write it down, 1 over, that is reciprocal of 1 over x. Reciprocal of 1 over x is x, right? 1 over means reciprocal. Reciprocal of 1 over x is x. Okay, reciprocal of reciprocal is the value itself. So one part is working fine. FOG of x is x. That is working fine. Now we have to find the other composition, and also we have to get the same result if these two are inverses of each other. So let's work on that second part. So also, if I want to find the f of x now, in the first part, we did FOG of x. In the second part, we have to do the opposite. That is, we have to do the GOF of x. Okay, if we want to find GOF of x, then this is equal to, hold on, screen share has stopped here somehow. Let me try to reshare it. Give me a second when I try to reshare this. Let's see. Okay. Can you see my screen back? Just give me a thumbs up. Okay, fine. So see, in the second part, we are trying to find this composition, GOF of x. So g as it is inside the function g, we want to plug in f of x this time. Okay, we want to plug in f of x this time. That is the meaning of GOF of x. Inside the function g of x. Now let's write the value. G of f of x is 1 over x plus 2. Can you hear me nice and clear? Okay, because my computer is saying my internet is not that stable. So I'm a little confused here. Okay, so we have g of 1 over x plus 2 because f of x is 1 over x plus 2. Now we have to evaluate this function g. Function g is the reciprocal of x minus 2, right? So whatever value is here, we have to take the reciprocal. Reciprocal of 1 over x plus 2. Reciprocal of 1 over x plus 2 is x plus 2, right? Because we have the reciprocal, then minus 2. Then we have a minus 2. Okay. In the function g, how does the function g works? It makes this x, whatever x is here, it will take the reciprocal of that and then subtracts 2, right? That's how that function machine is working. Same thing here. We have 1 over x plus 2. It will take the reciprocal of this. Reciprocal of this will be x plus 2. And then we have to subtract 2. So you can clearly see 2 and 2 get canceled. And what we get here is x. Okay, so from both sides, we are getting x. As we said here in the previous slide, f inverse, the composition of function and inverse in whatever direction you take should be equal to x. In that case, they are inverse of each other. The composition of function and its inverse is an identity function. And that's what we are seeing here. This composition is x, input is x, output is also x, identity function. Same thing here, input x, output is also x. So identity function. So we can write, hence f of x and g of x are inverse of each other, are inverse of each other. Okay, meaning of that is technically if you try to find the inverse of f of x, inverse of f of x will be 1 over x minus 2. Or similarly, if you want to find the inverse of g of x, that will be 1 over x plus 2. Okay, that is the meaning. So before we move on to next slide, if you have a question, you can ask me now, or I'll give you additional 1 minute here to finish up your writing if you have not finished it yet. It looks like there is no question. So let's go here. What I want you to do is copy this question. It is just like the previous question. There are two functions given here, f of x and g of x. Okay. I want you to check whether these are inverse or not. Copy the question and work on it. I'm going to give you about 3 minutes to work on this one. Okay, let's find out. Pooja, are we done?
No, I'm still working on it.
I can't hear you, Pooja. You're muted for. You tried to speak, but I didn't hear you.
Still working on it.
Still working on it. Okay.
Yes.
Okay. Good. Keep working. Okay, let's find it out. I hope we are done now. Chandana, what did you find? These ones together.
I don't think they're inverses of each other.
Okay, so why do you think they are not inverse of each other?
I don't know if I did this correctly, but in the end, I got f and then parentheses x cubed over 3.
Okay, for
And
which
then,
composition? Let's see. Let me write here. Did you do FOG of X first? Is that right?
yes, yes,
You did FOG of X and you said you did F of G of X. Did you do it like this?
yes,
And then F of, in place of G of X, you did X over 3, right?
yeah,
And then F, the function F does X cubed. So you cubed that,
mhm,
you cubed that, and you got X cubed over 27. Is that what you're trying to say?
yes.
Yes. So yeah, you're doing it right. So when you see this one, when you try to find f or g of x, this is not x. So you don't have to find the second one, it's true, right? So meaning of that is your composition f o g of x is not equal to x, right? If they are inverse of each other, they must be equal to x. So here we are getting they are not equal to x. So which implies f of x and g of x are not the inverse of each other, are not the inverse of each other. Okay, so you did it right, Chandana. I hope all of you did it right. But if any one of you have a question on this one, you can ask me now. So as I said again, when you are working on this type of problem, when you find that the first one is not equal to x, you don't have to do the second one. Okay, because for the functions to be inverse of each other, both conditions must be true, not just one. That's why when one of them is not true, that means they are not inverse of each other. If you're trying to prove that they are inverse of each other and you get x in the first, you have to check that is also x in the second one also. Okay. Okay, look like there is no question on this. So let's move forward and go here. This time we have the problem on graph. Please copy this question and try to sketch this graph. Make sure you have those correct points at least, okay, so that when we answer the question, the graph will make sense. So please sketch the graph. Okay, I hope you have your question written down. Let's work on this one. So you can see there is a function g of x given here in the graph. So function is given in the form of graph. We have to find g of 3 and g inverse 3. Now, if you look at this graph carefully, look at the graph, you can see that there are 2 points which we can read easily. For example, this point, we can read that easily. So let me point there. So that point over there, we can read that easily. So if you look at that point, that is x is 3, y is 1. That means this point is 3 comma 1. Okay, this point is 3 comma 1. And then similarly, here is the other point here that you can read easily. So that is, as you can see, it is 5 comma 3. So that point is 5 comma 3. Now, When x equal to 3, y is equal to 1 over there. When x equal to 5, y is equal to 3 over there. Okay, that's what we know. Now we are going to use these 2 points to answer these 2 questions. And you know that answering this one is not that difficult, but this one is new for you. To find g of 3, you know that when you go from x equal to 3, the value of y is 1, right? So g of 3 is equal to 1. So here, g of 3 is equal to 1. Right? It's quite easy for you. When x equal to 3, y is equal to 1. So g of 3 is 1. Our function is g of 3. So that is quite easy for you. I hope you got that one. Any question there? Is it good? Just give me a thumbs up. Okay. Now, if you look at the other point, thank you, Prakriti. You're hiding there, but I saw your thumbs up, which is good. Now, let's see. Look at the second point. Second point looks a little tricky there, because in second point, you can see the function g of 5 is a 3. G of 5 is a 3. That is given to you. Okay. But the question is asking us to find g inverse 3. Question is asking us to find g inverse 3. So look here what I'm going to do. I'm going to do a little bit of magic, and later on, this magic will be an easy trick for you. In the question, we have g inverse 3, but here we have only 3. So what I'm going to do is, in front of that 3, I'm going to take g inverse 3. If I take that g inverse on the right, I also need to do it on the left. On the left, I have g of 5, but I also need to take g inverse of that. Do you see that? I took g inverse on both sides. So in this step, what I did is I did g inverse on both sides. So taking g inverse on both sides. Why this? What if and only if? Okay, my internet is a little slow. You can see my writing. I can see that. Okay, it's back now. So we take g inverse on both sides. We got this. See, I took g inverse here, g inverse here. Now, if you look at the left-hand side, look at the magic here. G inverse g. If you take the composition of function and its inverse, right? If you remember from one of the slides here, all the way back here, if you take the composition of function f and its inverse, whatever value is here, the result is just that, right? If it is x, it is x. If here is a, it will also be a. So same thing here. You can see we have g inverse g, composition of function and inverse of 5. So this all value is equal to 5. Okay, so 5 is equal to g inverse 3. So the answer for the second part, look here, g inverse 3 is a 5. Okay, g inverse 5. And g of 3 is equal to 1. So this is the mathematical way of doing it. Okay, I use the mathematical concept here to do this. But let me show you something different. So these are the two answers. G inverse 3 is 5 and g of 3 is 1. I'm going to show you something different now. This is more advanced way of thinking. Okay, but if you want to think in a simple way, see g of 3. When I say g of 3, you start with x, and then when you go to 3, the value of the function is 1. Right? Value of the function is 1. So you start with x because it is a regular function. So g of 3 is 1. But when we say inverse, instead of starting at x, you start at y. Okay, you start at y equal to 3. Y equal to 3 is here. So if you start from there and go to the function and then go all the way down to the x-axis, what is the value of the function? 5, right? Inverse means you are going in reverse direction or opposite direction. Okay, so f of 3 is 1, but f inverse 3 means you start with the y-axis now is a 5. Okay, that's the easy way. Just look at the graph and answer the question. That is the meaning. So it's really easy to look at the graph and answer the questions. Okay, but how that is true, how mathematics behind that works, if you want to know that, this is how we'll be doing it. Okay, so for you at this level, the only thing that you should understand, if you cannot get all this math, okay, that's totally fine. You must be able to look at the graph and answer it. When we say the regular function g of x, you start with x and find the corresponding y value. That is the value of the function. Okay, and if you want to find the inverse, instead of starting at x, you start at y and find the corresponding x value. That is the value of the inverse. Because if you remember the original slide that we started in the beginning, for the function, we start from set A and we go to B. But for the inverse, we go in reverse direction from B to A. Same thing here with this graph. For the regular function, we go from x towards y. And for the inverse, we go from y towards x. Make sense? Is that clear? Yes, no? Okay. Great. Now, see, we work on so many different things, but if you look at the number of examples we have done, you may see that there are just 2 or 3. This is the one where you talk about, finding the value of the function and the inverse. But what is going on here when you're trying to find the value of the function and the inverse? You can see that for the regular function, we go from x to y. For the inverse, we go from y to x. That means x and y are interchangeable, right? And here we look at the composition, whether f of g of x and g of f of x are same or not. If they are same and equal to x, they are inverse of each other. Otherwise, they are not the inverse of each other. That's what we have seen here. And in the first one, when you're looking at the property, we saw that the graph of the function and the inverse are reflection about the line y equal to x, so that every point on the regular graph is the image of the function, okay, image of those points about the line y equal to x. Like 1, 0 becomes 0, 1, 4, 2 becomes 2, 4. Meaning of that is the domain of f is the range of f, and then range of f inverse, and range of f is the domain of f inverse. So these are the basic concept that we have seen so far. So in order to find, if you are asked to find the inverse of the function, meaning of that is you should be able to interchange x and y, okay? You should be able to interchange the value of x and y and then find the inverse. So here I have 2 questions. So quickly copy these questions first. Prakriti, are we done copying it? Yes. Okay. So now what I want you to do is, I know I have not shown you the example similar to this one, but what I want you to do is, I want you to try this as homework for this week. Okay. I'm not giving you homework on the online platform. I just want you to try this too. I'm not, expecting that everybody will be able to do it right, but if you do it right, I'll be very happy. Okay. Just work on this one. And after you completely solve these 2 questions on paper, send me the picture of these 2. You can just take a picture using your phone and send it here. Let me write the phone number on the chat. I don't want to write on the screen. That'll be public. Let me see if I write that phone number correctly. Okay, there we go. So please grab that phone number, save it for you. So what you'll do is you'll solve it completely first, and then take a picture and send it to me But when you're sending it, make sure you write your name on the top of the page so that I know who is sending it to me. Otherwise, I don't have your number or things like that. So I may not remember who is sending the picture. Okay. So that is the homework for today. Before you go, I know you have copied the question. Make sure you write that phone number. Go to the learning management site and then complete the attendance. Okay. That's all for now. But I'm expecting you to complete that work. Okay. So if you can do it today, that'll be wonderful. Tomorrow, that'll be wonderful. Don't take so long to solve those 2 questions. That's all. Have a wonderful new year. You know that it's New Year season, right? Do you know that it's our new year? Yes. Okay, good. Happy New Year to everyone. And I'll see you all next week. Okay. Bye, beautiful people.